All right, so let's get started then for this session. So it seems to be that we have the power of standards is here, that we have too many standards to connect to the beamer, but one of them worked. That's good. So, all right, so Mika Hatanpää is my name, and coming from Nokia. They're running the R&D for the data center activities. So what we are doing, and of course. From the beginning, when we started with this data center developments at Nokia, so we saw that the openness is really the way to go for us. So, and in that sense, we have adopted the OpenRAC version 2 as one of the designs for us, and also now we are looking at the requirements for the edge, and therefore also then planning to actually open and contribute what are our thoughts and what are our plans and designs for the edge data centers. So I seem to have a 1 hour slot. Okay, we already used, or the previous presentations used part of that, but let's see how long it will take. So quite a few topics on my list of things for today. So I will be talking about this kind of, or the topic of the presentation is open edge ecosystem development. More what I will be talking about is really what is the edge. There's some repetition from what Antti was presenting in the previous presentation, but I assume that there are some new people in the room, so I will quickly go through those things, and then the main part of the presentation is about the kind of requirements and how do we see what are the characteristics for the edge data centers and the hardware that goes into these locations. So first of all, I'll talk briefly about the kind of edge data centers positioning and the applications use cases, just quickly these, but then really for the requirements and what are the characteristics for these edge locations that we need to fit into or fulfill. And then I'll be talking about kind of building blocks for this edge solution. So what do we need there? So it's not just the server, but also what are the high-level requirements for these different building blocks for the edge solutions, and then in the end briefly about our proposal, what we are actually contributing or started to contribute to OCP. I'll start with that briefly, and then there's another presentation by Tomi Männikkö here after me or after the lunch, where Tomi will then go to the details of the design that we are contributing. So just a paid advertisement requested by the OCP Foundation. So Nokia is a platinum member of OCP and also a solution provider. We have been this for the past 3 years roughly. So then for the topic, so edge data centers and the positioning for this. So familiar slide from the previous presentation already, but really how do we see and what is driving these edge data centers very much in our business, especially is 5G. So 5G is starting to come and starting to materialize in the networks. Already pilots this year, more next year, and then going to commercial as well. But really the main requirements and the different kinds of use cases that 5G will be then enabling are related to lower latency. So we need to be able to provide lower latency for processing the data coming from the network, coming from the users, and also the throughputs are increasing massively compared to what we have seen with the 3G, 4G. And then increasing in 5G, and therefore due to this low latency requirements, especially we see that there's a need to move the processing power closer to the edge of the network. Okay, Antti showed this already, but just briefly some topics about this. So we kind of started the developments from these central data centers that are here on the right side of the slide. There we are deploying this, you could say, traditional data center gear, targeted and of course optimized for the telco use cases in our business. But really OpenRAC version 2 is what we are using there, And we have done some enhancements for the OpenRAC version 2, but those are also being contributed back to the community. Then when moving towards the edge of the network, so basically to the left-hand side of this slide, so we see that okay, there are regional data centers. There's a few of those typically in the telco networks, like less than 10 depending on the size of the operator network in overall. But then when going towards the edge, so the number of sites increase from few sites to tens and hundreds and even thousands of sites in the networks. And also the requirements and the kind of characteristics of these sites are changing. So central locations can be and typically are more like data center, so they are capable of hosting very large equipment, high power budgets and high cooling requirements are fulfilled there. But then these edge sites, and especially the far edge sites, are typically they are kind of telco central office sites or radio sites even. And from that point of view, they don't have the similar capabilities as this kind of data center like locations. So they have much lower power budgets. Really, the footprint that we can fit into these sites is much smaller, and so on. And kind of from the distance from the end user, I tried to put here some numbers like these edge sites are typically 20 to 40 kilometers or 10 to 40 kilometers away, so that we can achieve this kind of less than 1 millisecond round trip time for the computing. Or let's say the traffic that then goes through these sites. And then the kind of aggregated edge, where some of the other functionalities go to these can be like 200 to 350, 400 kilometers away, and but the latency then goes up in these locations already. So, but okay, I'll mostly now focus on this what we call far edge in our terminology, and to some extent to this aggregated edge sites. Overall, briefly, just to target what we have and why do we want to do this as is. So is that in order to reach the low latency, the content needs to stay close to the edge of the network or close to the end user that is providing and using the data. And then also let's say, of course, that also means that there is no need to send the big data to the network or to watch the core of the network. Then, of course, that's then limiting also the traffic that then goes to the transport network, and it's also an important optimization factor for building the networks. Some things about the edge use cases and applications then. So the main use case for us is the one here in the middle, which is the Cloud Run, which was already discussed in the previous presentation quite a lot, and then so that's, I would say, the primary driver for building how we see for building the edge data centers. But then actually it's a good thing in that sense that once the Cloud Run actually is driving the deployments of this computing power and cloud computing power to the edge of the network, that then actually gives the possibility to also start deploying other kinds of applications to the edge. Then, of course, mobile edge computing or this kind of multi-access edge computing there's a lot of different kinds of use cases defined for this that are requiring the low latency service for the applications. And then also 5G network slicing, like for example, network slicing for automotive, for example, is one of the good use cases which actually then can benefit from the edge locations. And kind of edge actually makes it possible to provide the slices for the different uses from the edge of the network. Very busy picture, so I'll not go to all the details of this one, but how do we kind of envision that the edge data centers are being built is that there are bit different kinds of hardware on this edge location, so it's not just the servers, but there's also need for some acceleration capabilities or more optimized hardware that then fits better to the use cases that we have there. But on a high level, what we have there is like that we have a pool of general purpose computing hardware where we can run certain applications. Then we have some hardware that is then more optimized for user plane capabilities and really kind of with high traffic throughput type of applications. And then there's some dedicated hardware that then runs certain functions in the network, like for example the baseband processing for 5G or 4G, and also some fixed networks applications like OLT, virtualized OLT, for example, can benefit of this type of hardware. And just as an example, for example, that there was some questions about the kind of implementation of the Cloud Run and the kind of CPRE, the front hall interface. The front hall implementation is something that to some extent, yes, you can do it virtualized, but it's not very efficient. So you definitely will need some special purpose hardware to process the CPRE eCPRE conversion, for example. Okay, I'll not go to all the details here, but as said, so a lot of use cases what we see that are emerging, especially with the 5G and with the cloudified architecture of the networks, and which require then the processing power to go to the edge of the network. Some few words about the landscape also for this edge computing. So there's a lot of different kinds of forums that are working with this. I think the other forums mostly are not working with the hardware that much, but they are really working with the use cases and different kinds of applications and implementations or software implementations that go to the edge. But kind of where what we are looking quite a lot is for example, Etsy. Etsy is one key partner that is defining the what is this mobile edge computing about. There's a definition here in the bottom how Etsy, for example, defines this multi-access computing that offers application developers and content providers cloud computing capabilities and an IT service environment at the edge of the mobile network. And this environment is characterized by ultra-low latency and high bandwidth, as well as real-time access to the radio network information that can be leveraged by the application. So that's just from the Etsy as such copied, but I think that very well describes also what we are trying to achieve with this. Other forums, like it's quite new. This open edge computing, Akraino is what we see as a very important project defining the cloud stacks for edge and so on. But a lot of these, maybe every week something new, so that's a bit of a challenge as well. So, and then of course there's the kind of other players that already offer solutions and for the edge as well, and kind of, but okay, not more about them today. Then some high-level requirements for or rationale for this new form factor that we are proposing for the edge, and why we are proposing that in the first place. So, as said already, so there are facility constraints, especially for the edge, and how we see is that there are, let's say, edge facilities are often existing radio or central office sites of telcos. In our space, there might be other businesses, of course, where there are something different. But this is what's important for us and what we are looking at. And the limit or constraints are related to the space, power, and cooling. And as an example, the kind of fully equipped OpenRack version 2 weighs about 800 kilos or can be even more than that, which means that it's about more than 1,000 kilos per square meter, which often is too much for this location. So if these edge sites are, for example, on the 10th floor or 20th floor of the building, then actually the floor load capacity is not enough to host this equipment. Then the rack depth is also a problem in many of the locations what we see, and in a typical central office locations, the maximum depth is from 600 to 800 millimeters. So we're compared to the typical open rack designs, for example, which are more than 1 meter deep, which simply will not easily go to these locations. So we see that the maximum that we want to achieve as the maximum is 600 millimeters for the equipment for the edge to fit there, to fit to all the locations. Then so 19-inch rack infrastructure is also often present in those places, and in many cases, especially if the installation is smaller, there's a requirement that okay, you need to install your new edge gear to this existing rack. So no, not possible to bring into something totally new there. And in some cases, those racks are next to the wall or totally closed from the rear and things like that, which then gives additional challenges. So then other limitations can be related to elevator capacity, delivery path height and things like that, which has actually already we have seen in many cases where we are today, let's say, bringing Open Rack version 2 designs into telco sites. Actually, we cannot deliver the rack as equipped there, but we just have to actually dismantle everything from the rack, and then we can bring it into the place, and then we have to build it again. But that's not very convenient. Something more about these facilities. So the power is typically this 48-volt DC power feed that there is and exists, and of course people want to reuse that not build something totally new, or because it's there, it's providing the battery rooms are there, providing the reliability for the power feed. Then there, on the other hand, there's some challenges coming from the fact that when people are using AC, there's a lot of different variants of AC that need to be supported, but yes, there are solutions for that. That's certainly with different kinds of PDUs and PSUs. Then cabling can be from top or bottom. If there's a raised floor, both ways need to be supported. Edge site power budgets, as already said, so can be quite limited. So it can be, let's say, as low as 4 kilowatts or even lower than that in some cases. Of course, then the question is that if you have very limited power budgets, then so does it really make sense to bring equipment like this or even try to build an edge cloud into such locations? Same then applies to the cooling. So power and cooling always go together, that you have to have those roughly in balance to make it feasible. Then one challenge might be that there are requirements from cooling point of view that you have to be able to cool from front to rear or from rear to front, which is a bit strange to a server that if you need to kind of reverse the airflow there. But it is possible, of course, and that's what we try to achieve. And the reason for this is that in some cases the racks are kind of actually located so that they are like 10 centimeters from the wall, and in those cases you cannot kind of push the hot air to the wall, it will just come back, but you have to pull it from there and then reverse the airflow. Then environmental, so environmental requirements are still there, so pretty much the same telco environmental requirements that we have seen there all the time for telecoms, and they are not disappearing anywhere when we are going for this cloudified or NFV architecture. So there are requirements related to safety, EMI, EMC, temperature tolerances, seismic tolerance, RoHS or this kind of and waste handling, chemicals handling, and fire resistant energy efficiency as a new requirement that's popping up more and more, and then acoustic noise, for example. So it's kind of all the same things that have been there, which creates a lot of challenge, but of course can be implemented that to take this into account when designing the solution. Then it just needs to be verified kind of against the regulatory and other customer compliance requirements. So mostly it's about the NEPS compliancy. So NEPS compliancy is there. I don't specifically mention NEPS here, but NEPS is actually behind many of those other requirements listed here. So we have been using now OCP OpenRec version 2 for a while, and we do see that there's a lot of good things in that one. So it's an open design first of all. So it's modular design. There's an ecosystem of companies and adapters for this design, and it's very energy efficient design overall. There's good proof points from the community for that even. And then it's vanity free, toolless, and quite dense overall. And but that said, so the one challenge is that it's not easy to fit this into the edge locations. And due to that, so we need to have something smaller, but what we would like to see is that we can still kind of keep these good characteristics of the open rack design also in the edge. Let's say it has to be fully front operated open rack like toolless design or serviceability is targeted vanity free design is what makes sense. And then central power supply, for example, that we see also in the open rack design makes sense and provides better power efficiency overall. Then something about the serviceability. We did a study of this while ago, and certainly we can see that the open rack from serviceability point of view provides a lot of improvements, like 4 times faster completion of required hardware maintenance tasks. If you, for example, need to change a server or a NIC card or something, it is actually much easier with this toolless design, which is fully front operatable, and so on. So that's just as a target. We definitely want to see similar goodies in the edge designs as well. Then a few words for summary for this one. So the existing data center equipment design, like the let's say most 19-inch rack mount designs, or even the OCP OpenRack version 2 designs. So those are targeted for kind of heavyweight or let's say real data centers, but these systems are considered too heavyweight for the edge locations. And so due to the constraints of the edge environments, so we need a form factor that then fits better to the edge locations and fulfills the requirements of the edge applications or telco applications in our use cases in a cost-efficient manner. And so the OCP design principles, as said already, so this is what we still also want to keep, and kind of combining the OCP principles with the requirements of the edge. It creates, in my opinion, a good basis for the edge form factor design. So then something bit more detailed about this different building blocks for the edge. So for example now a rack, and so we need to be able to install the equipment to indoor as well as outdoor, and so it's in general we see that the rack is not a mandatory part of the solution, but still we need something where we can install these systems or the edge cloud solution into. But as said, so in many cases there's also existing racks in the locations where we have to fit into, and then let's say that what we also need to achieve is that we have the the kind of scalability from very small installations and very small systems with just a few servers to a full rack level systems. But in general, okay, what I'm also trying to say here is that compared to, for example, OpenRack version 2, which in a way the minimum configuration is one rack, because you have the rack is a mandatory part of the solution that you can get the servers powered up. Even this is not working in the edge, so we cannot require that we have to have our own rack with certain type of power feed in these locations, but we have to be able to fit into something existing there. So in that sense, it has to be smaller so that we are scalable from very small to bigger environments as well. Then indoor and outdoor installations are possible for the equipment. In that sense, the edge equipment needs to be tested and certified for both installation locations. In the outdoor, of course, you can do a lot with the cabinet or even some modular data center, so you can kind of adjust the environment for the server with that, and that's I think a good approach in many cases. Indoor rack maximum footprint is the 600 by 600, what we see, including the doors, preferably. Then back-to-back or back-to-wall rack installations might be there, and the equipment needs to kind of support these use cases. Then racks may be closed from the rear side, as already said. So we have these cases already that we see that there's basically there's no door in the rear side, but there's just the kind of a mesh there, which is totally welded to the rack frame. You cannot open that, and in that sense, we cannot afford then, or the design has to be done so that there is no need to go to the rear side of the system. So also the outdoor cabinet solutions may vary, but a lot. But in general, the equipment must support the outdoor installations, as said. So there's some pictures, and actually the one picture, actually two of these pictures. So the one there on the upper right-hand corner is the one outdoor cabinet that we are also showing in the Nokia booth here. The same is actually, this is in the second picture. This is the same outdoor cabinet, just installed in the other way around, and then the other rack picture there is one rack where we actually need to fit into that is totally closed from the rear side. So power feed requirements. So as I think I already said, so there's a lot of different variation for the power feed, and in general, it's a bit of a challenge to support or to build equipment that then can be installed globally to all the different countries because of this. Rack level power feed in general requires the, let's say, PSUs and PDUs to be selected for the solution, but we kind of leave it open. But those are of course needed as building blocks if you want to build an edge cloud solution. Centralized power supply for more than one server. So we see that it's a preferred option in that sense that it provides better efficiency for the power feed instead of having like, let's say, like you have for example in rack mount servers, you have the PSUs in every single server separately. Okay, something about the voltage ranges that need to be supported. So this minus 48 volt is the typical telco power feed option that is existing in many of the telco sites, but it's I would say AC is also coming more and more to the picture, but for AC especially, there's a lot of different variants that need to be supported. With those mentioned here, we can fulfill most of the locations and sites. Then typical PSU voltage options, okay, minus 48 volt or let's say kind of wide range from 100 to 240. AC works fine. overall, the power feed needs to be redundant, so we need to be able to support redundant power feeds from different sources. Then a few words about thermals. So how we see, because of these locations where we are installing these systems to, so it's important that we are kind of, it is pretty much coming from the ETSI and NEBS requirements that we need to be supporting the operating temperature ranges from -5 to 45 in kind of normal situations, and then as a short-term kind of temperature range in case of failures, we have to support from -5 to +55 C, which is the kind of typical NEBS requirement. And as said, so front to rear and rear to front cooling for the equipment is something that needs to be supported. Then coming to the server, which is kind of a key part of the contribution that we are making. So let's say general purpose servers are, we can say that they are the main building block of the edge data centers in the end. So the server performance requirements may vary depending on the planned workloads, but in general we have to remember that we are building a cloud platform, so it's not the kind of a bare metal application and just a server that fits into the requirements of one single bare metal application, but it's a multi-purpose cloud platform, and in that sense the CPU power that we need to have there and want to have there is actually quite high. But then on the other hand, due to the depth limitations, we have kind of come up to the solution that we are proposing that it's a single socket design instead of dual socket design for the server. And let's say what's our experience is that 20 cores is enough for running running, for example, kind of OpenStack KVM based cloud implementation. Of course, we can benefit if we can get much more cores, but it seems to be kind of sweet spot at the moment, at least from cost performance point of view. Then, as already said, so single socket servers are what we are proposing, and the reason for that is that they fit better to this shallow chassis depth, but also actually especially for high throughput applications like EPC, for example, and Cloud Run as well. Or Cloud Base Station, especially the single socket works in that sense better, that there is not the NUMA effect of having dual CPU designs, where then you need to cross or go across the UPI bus when you are accessing memory or I/O that is behind the other CPU. And we have a lot of good examples that actually, as said, so single socket design works much better for these high throughput type of use cases. 400 watts per CPU in a 1U server is the target. What we have then for 2Us, it would be roughly double or so. The server chassis must fit into a 19-inch standard rack that is, as said, so 600 millimeters deep, and the chassis depth, which means then that the chassis depth for the server itself should be limited up to 45 centimeters, because we also need to fit the cabling as well as the doors into this 600 millimeter depth. Then redundant and hot swappable power supply, as already said, and redundant fans, redundant connectivity should be supported. So that's still very much requirement coming from telco applications, and because of the reliability requirements for the services that we are building. Storage, not too much to say about the storage solutions, but in general, I can say that the storage requirements are quite modest for most of the telco applications. And then there are, of course, some applications like CDN or content delivery, which has other kinds of much higher storage requirements, but this is, I think, something that needs to be looked into separately. For robustness purposes, the hot swappable storage as well as the write support is something that should be there. Commodities. So with commodities, I mean things like DIMM modules, NIC cards, SSDs, and so on. So it's something that we want to use standard commodities as much as possible. So we don't want to build special purpose NIC cards for edge, but we want to use standard PCIe cards or OCP mezzanine cards. Which is we see important. Then for mass memory also 2.5-inch SATA or NVMe SSDs should be supported or M.2 as well. Then of course there's the new form factors, NGSFF, EDSFF are coming as well, and especially now if you think that the edge we need to have a more compact server design, so it makes a lot of sense then to start using these more compact storage or mass memory options as well. I don't want to say which one is better or which one should be used. There seems to be still the fight ongoing about that. So, RAM memory should be implemented with standard DDR4 DIMM modules. Compared to, for example, in some other earlier designs, for ATCA, for example, we were using different kinds of a bit more special DIMM types, and it was always a challenge to find the source or get a good pricing for such designs that are not commonly used. Then, okay, in general, just about the commodities, I'm saying that okay, what we want to achieve with this use of standard commodity form factor is good availability. They are supported by wide ecosystem. There are many kinds of use cases and technologies available for these standard form factors. They are cost efficient in general, and there's no lock-ins as well because of the multi-source that is available for most of these different commodities. Acceleration then briefly. So today, telcos are using a lot of special purpose designs for acceleration. It's like built with FPGAs, DSPs, network processors, ASICs, GPUs as well, starting to be used. But also in the edge cloud, we see that there's a requirement for certain functionalities to be accelerated, even if the overall target for this, as said, it's a cloud. So and in that sense, the target is that the functionalities are getting virtualized as much as possible. But for example, radio baseband processing for 5G, yes, you can virtualize, but then you need quite a lot of servers, and it doesn't really make a lot of sense. So there's a lot of challenges with that. Some packet or acceleration of packet processing, security, and encryption. And then, of course, AI ML is especially, let's say, for edge training is maybe not the most important use case, but inference certainly is, and for that there's a need for GPU type of solutions. And then for, let's say, video seems to be also actually quite important, and there are different solutions for supporting video encoding or AR applications like GPUs or some FPGA-based solutions as well. But in the server, the idea definitely then is that we need to be able to support these kind of use cases and different types of accelerators. But the form factor of the accelerator, how we see, is that in most cases it should be the standard PCIe card, for example. Then which then means that so the server design, what we target to is something then that it needs to be able to host, as said, as many as possible PCIe cards and different sizes of PCIe cards, even up to the kind of full height, full length, double wide large GPU cards. So. Then, okay, synchronization is something that needs to be supported. So it's still something that the radio network processing requires very much. And so in that sense, the system needs to have the high precision grandmaster clock accessible, or it needs to be able to get the sync from there. And from the, let's say, for most of the use cases from server point of view, this 1588 is sufficient, but it's if needed, let's say, we see that for example, switches should be supporting sync E to get more accurate timing through the network. Switching briefly. So it's a lot of different building blocks. So it's not just the server that you need to build an edge cloud. So there's a lot of components that need to be there. Switching, if you think of the servers and the kind of capability of the servers, that what they need to, what is the connectivity for them. So typically, even today, it's about 100 gig per server, or even more. And the edge data center design is we see that it would be typically based on the redundant spine and leaf architecture or topology for the networking. Then for the servers, this 100 gigs means that it's not just 100 gig link, but it would be typically 4 times 25 gig redundant links going to the redundant leaves then. The amount of cabling, especially in bigger installations, is quite big. So we see that, and as of today, at least, the duct cables is the most cost-efficient way to do this, and this is available solution for building this up to 100 gig links to the servers. One challenge is that the switch also needs to fit, of course, into the same depth of 600 millimeters, meaning that the chassis of the switch is max 450, as the server chassis depth should be. And the switches also should be fully front operatable, including the power feed, which is not the case as of today quite often. Firmware, maybe just very briefly, that what is important for us is that there's a full remote management capabilities for the servers, because the servers might be hundreds of kilometers away from the location where some human is operating these, from this one operational center, they could operate hundreds of edge sites, which then have in total thousands of servers. So it has to be fully remotely managed, and also it has to be very reliable in that sense that it's not possible that somebody goes there every week to fix something. Equipment, how we see is that it's preferred to be managed in a similar, so all the equipment, including the servers, but also if we put something else to the edge cloud, like switches or some accelerator solutions. So we should be having a uniform way to manage this. BMC is the uniform way for servers, and BMC is also coming to the switches, especially in OCP. OCP has been driving that, and we do see that as a good trend. Overall, then Redfish as an interface is what we propose as the interface for managing the equipment, or let's say for the hardware management of the equipment. So it's getting more mature nowadays and seems to be fit for the purpose really. Security is must. Redfish is providing good security already for the management connections compared to IPMI, for example, which is totally unsecure. Also because it is to be remotely managed and far away, so it needs the firmware as such should provide high quality self-diagnostics in case of issues, and also self-healing capabilities. So it never stops trying. That's the purpose. It should never fail in the first place. Then, okay, maybe I'll skip this. It's a bit more about the software part. Then for the open management, so open management is now I'm not just talking about the management of the individual equipment, but really on the kind of data center management equipment, and especially now that we are talking about edge data centers. We don't want to manage separately each of these edge data centers, but we want to manage them as a kind of one big entity. And that means that we need to have a kind of a second layer management solution, which we don't have standardized as of today, but the kind of when interfacing from the kind of central location, the different equipment, we of course propose that let's say Redfish is the primary interface towards the equipment that is there, but also we do see that there would be a good opportunity to standardize some of the let's say management functionalities on this second layer of management of the hardware. And for example, switches as of today are many times managed by SNMP or CLI, and so there's no common way of managing switches. Every vendor has something different, and it would be nice to see something that is the same. As said, so BMC and Redfish would be good for the switch hardware management as well, and other equipment in the systems. Multi-vendor capability is maybe one thing still to highlight this, because okay, we don't see that it's only Nokia, but it's of course a lot of it can be coming from different vendors, and there has to be the capabilities to integrate easily equipment from anybody. All right. Then some summary for this part. So why do we need new hardware form factor for the edge data centers? Why are we proposing this? So we see that the edge sites are existing telco, central office or radio sites, and the traditional data center gear is simply too large and too heavyweight for these locations. So something smaller, more compact is needed for these locations and use cases. We see NEPS compliance of these telco requirements still very much valid for these locations and the new equipment as well. Power budget, because power budgets are limited, and the support for variety of power feed options is important. Network functions virtualization in general is driving this cloudification of all services to the edge of the network, and let's say general purpose CPU servers are preferred for the virtualization platform. Nothing different. Then and like I say that okay, for new telco 5G and mobile edge computing applications can benefit from acceleration capabilities for processing and networking, and for this purpose we need to be able to support these accelerator implementations in the equipment. All right. Then just a few words about what we are going to propose. So there will be another session, not going to very much more details than this one for the proposal, but what we are proposing is an x86 based server solution which has a small chassis that's a 3U high chassis fitting into this 600mm deep rack, and so it's compatible with this 19-inch rack designs. It's the design as such, what we are proposing now is a 3U high, but it can be, let's say, varying from even 1 to 2U up to, let's say, 7Us maybe makes sense. Then if you build a bigger chassis, then I don't think it probably makes sense. Then you should put more of those, just stack them on top of each other. Then, as said, so we are kind of proposing to use sleds of 1U or 2U in this chassis. Then it's fully front operatable, so cabling and open rack-like toolless serviceability is what we target to. And then support for high-end accelerators is there. and then high availability, let's say, is implemented in that sense that we have redundant fans, hot swappable storage solutions, etc. And airflow is configurable from front to rear and rear to front. Then from the environmental point of view, we have tried to take into account all the telco requirements in terms of NEPs and ETSI and for example for the extended temperature range as well as for seismic compliance, for example. Maybe I not go now here to the dimensions, power management options, commodity options, what we have there. Tommy will talk something more in more detail about most of these. But then to the last part, so what we are proposing is that what we see important is that we have now done something, and we are contributing the first design of this open edge server to OCP. But we do see that there's a collaborative effort needed to define the solution further that then fulfills the needs of the edge use cases, and that would be supported by an ecosystem of suppliers as well as adopters. So we definitely we are proposing that we are creating a kind of subgroup under the telco project that would then start looking at the requirements and kind of further development of the edge solutions. And so what we are now contributing, we see it as the kind of first step, and we definitely believe that that's a good solutions to start with, but I think there's a lot of way to go forward still. So in that sense, we do invite the OCP community to work with us on this edge designs. So maybe that's kind of where I will not go to that part anymore. So thank you from my point of view, and last slide. So now the design that we are contributing, there is actually already the draft specifications available under the telco wiki pages if you want to see some more details. But the design is, we have the hardware available in our booth downstairs. All right, any questions?
So hitless upgrade is always a target for the telcos. So do you see the software in this environment focusing on hitless upgrade, or do you see other methods like moving the application over, you upgrade and then moving it back, which is a little bit easier if you...
Yeah.
But now you need duality at the edge.
Yeah, for some components we do see that there's a need for kind of duality or redundancy, but of course the cloud platform as such, the target is that basically we can use the kind of for example OpenStack evacuation capabilities to move the workloads to another server or to another node, and then upgrade the other part of the system then meanwhile.
Yeah, but if latency, low latency is important, and it needs to be in that edge, that may not work, right?
Yeah, for sure. But I think the important is also that when we are building cloud to the edge even, so there needs to be some, let's say, additional capacity that it's not like dimensions so that you are not able to move anything anywhere. And especially during the kind of slow traffic time, you should be able to move some of the functionalities to another node or to a kind of neighbor node, and then do upgrades or maintenance operations to part of the system.
Yeah, so in terms of the application, do you have any focus on the mature applications on the edge computing in the future? For example, the machine learning in the fog, and also in maybe the intelligent manufacturer. So is there any application field you have the focus for the edge computing?
Well, maybe I don't want to go to forecasting as such, so my crystal ball is not that clear. But for us, the first use cases that we see, for example, this is the vRAN implementation, so virtualized radio access network. Then there are some use cases coming from the mobile edge computing side as well, especially for kind of video and augmented reality, for example.
No, I actually had a question on, you just mentioned OpenStack. Meaning when you have these kind of services at the edge, I assume it's going to be, very minimal, right? Meaning just a handful of servers. So do you really think OpenStack would actually, meaning I've heard, it does require quite a bit of overhead.
Yeah.
So how do you see that going forward?
I skipped the slide, but so what we are looking at is that yes, we do see that OpenStack as the kind of management platform for the cloud infrastructure is okay, but I agree that let's say the standard OpenStack implementation as of today requires too much server capacity. So in many cases we see that it's a minimum of 5 nodes before you can start putting any applications on top of that even. What we have done so far with the OPNFV is that we have a kind of a fine-tuned OpenStack implementation so that we can actually survive with 1 node and just a couple of cores per server that then are taken by OpenStack, and all the rest is left for the applications. But it requires software work as well to get there. But fully agreed that we need to work on if we want to use OpenStack, and we do see that as a good alternative, that really to optimize the OpenStack use of resources for the edge locations. And I believe Accra and these projects are looking at this.
Right, yeah, meaning I was going to mention the crane as well, because that is targeted more towards the edge, and this would be a good use case for that. And I think as a follow-up to another question, on the applications, do you plan to support, like for example, like an OLT type of application, a virtualized OLT, which is an open software today, work is being happening in ONF as a collaborative effort. So do you see that as potentially running on those servers?
Yeah. Well, I do see personally that OLT, for example, would be a virtualized OLT functionalities would fit into these servers. I'm not in the position to say that what will Nokia do and what we will do for that area. So, but can be discussed offline then.
Yes, any other questions? Okay.
Maybe a little bit naive question, but you're part of the R&D group at Nokia, and how far into the implementation you think Nokia-wide, like company-wide, you are? I know you mentioned hardware, I will come and see you, but just interested because it kind of represents a shift in what you guys do.
Yeah, it's a shift, and let's say overall, of course, the edge is a new thing, so it's I would say it's an emerging market overall, and very much dependent on the 5G deployments and when 5G is coming. But as Antti said in the previous presentation, we do believe that there's some mobile edge computing use cases, for example, that are definitely not 5G dependent as such. From deployments and point of view, so we will have the systems commercially available by the end of the year, and so we are starting to deploy already then. All right, if no other questions, I guess I'm standing between everybody and lunch, and so.
Thank you. So I guess it's lunchtime, and we'll be back at 1, right?
1, yes.
Yep. Thank you.